Let's do this, winners. Getting down with some radicals. Solving.
Because we're radical.
We are radical. And so are you. Don't let anybody tell you otherwise. Alright, a couple examples here real quick. Solving, first one's pretty straightforward. Take a look. You got to isolate the radical, so we'll subtract 3 on both sides. 8 minus 3 gives us the 5. And here's the new step for Unit 4. We square both sides. So this entire side is squared. This entire side is squared. And the square root and the square are inverses, so they cancel each other out. And then you're left with 25 on the right side. Add 3, divide by 2, you get your 14.
And then after you get your answer, make sure you check it in the original.
Look for extraneous solutions.
Yep. So now on this one, first thing we got to do, same thing, isolate the radical. All right, so divide by 3. There's that little bubble in the top corner. It says 1/3 power is the same as the cubed root. So how do we get rid of that? Raise both sides to the power of 3.
You got to cube it, cube it.
Nice. All right, so the cubed root and the cubed go away.
Goodbye.
X plus 1 on the left. 4 times 4 times 4, 64. Minus the 1, get 63. And then you can check it again, just to make sure we know what we're doing.
Alright, so we did the big uglies a little while ago, and there's a couple more that are big and ugly. This is one of them right here.
Alright, so this one, we got a problem because we got 2 radicals. So can we just subtract them and say it's just x plus 1 underneath?
Yeah, why? Oh, no!
No,
You
why
can't
not?
do that?
They have to be the same underneath, just like when it was numbers. So first thing we do is we're going to add that square root of x to both sides. So we get our square root on both sides. Then same steps. We're going to get rid of the square root on the left first. So how do we do that?
Square that sucker.
Alright, which makes it alright on the left hand side because you get 2x plus 1. But on the right, you have to do your double distribution. 1 times 1, 1 times square root of x times 1, square root of x times square root of x. And you get that whole mess, alright? So, it's fun.
Yes.
Yeah.
Fun with radicals, continuation.
Okay, so...
Combine like terms.
Yep, but we still have a problem because we still have that radical in there. So we subtract the x on the right from both sides, subtract the 1 from both sides, and so we end up with x equals 2 times the square root of x.
Okay, a little bit of algebra here. We'll divide both sides by 2. The 2's cancel out, and that leaves you with x over 2 equals the square root of x. And just like before, to get rid of a radical, well, to get rid of a square root, you square it. And that's exactly what we did here. And we got rid of it. It's gone, and then you square the whole left side, you get x squared over 4. The rest is algebra. The rest should be old news. And you go ahead and multiply both sides by 4.
Subtract that 4x because it's quadratic, set equal to 0. Factor out your x.
Factor.
This factors, or you can go through and do the quadratic formula because that's a lot more fun and a lot more work.
Very fun, very more work.
Yeah, and say we got x times x minus 4, set each one equal to 0, so x equals 0, and x equals 4 is your other solution. After that, you got to check it. So you plug them in there. This one, you come and tell us tomorrow if they work. One, both, or neither.
Yep, 5 points too. Well, for Reddy's class, I don't know about winners.
I'll give him 6.
Okay, you're way cooler, dude. Hey, bring questions. That's the big ugly for radicals. Have a good night.